Letter B. Our goal here is to write at least one equation of this graph right here. And it looks like we've got two things marked on the y-axis and two things marked on the x-axis. Now, those dotted lines are not asymptotes. Not every dotted line is an asymptote. Sometimes they're just guidelines, like our sinusoidal axis, right? And our new y-axis. These are just there to show you that the high point is at 6 and the low point is at 5. Okay, that's all they're there for. So let's go ahead and see if we can mark this up and get all the information that we need. So what's the first thing that you think we can obtain from this graph? Let's the amplitude. Yeah, so let's write it. Whoa! You see how thick that is? Someone came in when I wasn't looking and changed it. Dastardly deed. We can call that person a dastard. A, B, C, D, P, and R. Okay. Why? You said we can find the amplitude. I think you're right. What would be the amplitude? 1. I don't know if that's quite right because look, 1 is the distance from the high to the low. If we were to draw the sinusoidal axis, remember the sinusoidal axis runs right in between the high and the low, and the amplitude is the distance from the axis to the high or the axis to the low. So now you know what the real amplitude is. What is it? It's 1/2. Yeah. Hey, and that means we can find our D value now, doesn't it? What's our D value? Or D, sorry. 10 over 2? 11 over 2, right. It's halfway between 5 and 6. You come down a half from 6 or up a half from 5, and you get 5.5 or 11 halves. I don't care which one you use. I'll just use 5.5 here. For 1/2, I'll just use 0.5. I'll just do it all in decimals this time. Might as well. Why not? Whatever you want to do. They're both fine. They're both exact answers. That's what's important. If you were to use 0.33333 instead of 1/3, I would then have an argument with you to use 1/3 because it's more exact. All right. Let's see. What else can we get here? The C, we're going to wait on the C depending on which equation that we use. So we're going to wait on that. The range, can we find the range? Yeah, the range is going to be from 5 to 6. Yeah, so I'll say y epsilon beefy bracket 5 to 6 beefy bracket. The period and the B, that's the last thing that we need. And they're related to each other. Yes, yes? They're related to each other, like Seth and I are related to each other. Y'all know that already. These are related to each other. Which one do we get from the graph? Do we get B directly from the graph or P directly from the graph? P, the period. Okay, so we have a high point marked at 15, and we have the next low point marked at 100. So that is what fraction of a cycle from a high to a low? That's a half cycle. So yesterday we saw 3/4 of a cycle. Today we're seeing a half of a cycle. So let's go ahead and write that down. A cycle I'm going to call the period. So I have this equation. I know 1/2 the period is equal to, what's the distance between 15 and 100? 85. Good. So if the period is half the period is 85, then the full period would be twice 85, which is what? 170. Good. So that is going to be our period. And now can we find the B value? Yeah, the B value is now 2 pi over P, which is 2 pi over 170, which if we simplify is back down to pi over 85, pi 85ths. Very good. Now we can write an equation. We can write a positive cosine because we have a high point marked, and we can write a negative cosine because we have a low point marked. Let's go ahead and do those. So I'll say for a positive cosine, we're going to have f of x. Don't forget f of x equals. For a positive cosine, the amplitude is, I'll just stick with decimals, 0.5. And then we're going to have a cosine of, parentheses, pi 85ths, another parentheses, x plus or minus something something, plus 5.5. And again, we've done this before once we've created our own graphs. So if a high point corresponds to 15, what is it going to be inside the x part? Is it x minus 15 or x plus 15? X minus 15. Very good. We're shifting over to the right. And now we have a low point labeled. A low point is going to be a negative cosine. So I'm going to write a negative cosine equation, and it'll be f of x equals negative 0.5 cosine of pi 85ths times x plus or minus something something plus 5.5. And if I want to shift over to the right 100, is it going to be plus or minus 100? Minus 100, yeah, okay. Now, ooh, I put 1,000. Getting greedy. Now I have to write a sine or a cosine. So we don't have the rest of the marks labeled, do we? So I need to mark this point here, which is on the axis. That'll be a negative sign, and I'll just mark this point right here, which would be the next point going up. That'd be a positive sign. So remember, how far apart are these critical values from each other? What fraction of a cycle? Well, just in general, every critical value in Sahala and Chala are a fourth of a cycle away from each other. So if the full period is 170 or a half period is 85, a fourth of the period should be half of 85, which is what? No calculator. We did it together. We all know what cosecant of 5 pi thirds is, but we pause a little bit for half of 85. Okay, which is fine as long as we get the right answer. So let's go ahead and label it. What's 15 plus 42.5? 57.5. Yeah. And this one we'll all do together. The next critical value is 100 plus 42.5, which is what? Woo! Finish strong, baby. Okay, now we can write the two other equations. Let's do the negative sign because it comes up first. We'll say f of x is a negative 0.5 sine of pi 85ths times x minus 57.5, close, plus 5.5. Make sure you close that second parenthesis. If you're doing this on a test or a quiz and you forget to close that second parenthesis, you're not gonna get credit because that second parenthesis then would include the 5.5 inside the angle, and that's not good, is it? So little details like that matter. Okay, and then the last one we need is the positive sign. So that's f of x equals positive. We don't even have to put the plus sign. Positive sine of pi 85ths. Parentheses x plus or minus something something plus 5.5. And now we're looking for what point on the graph? A positive sign is where it's where? Midpoint going up. We call that an axis going high. So that is over at 142.5. And if we need to shift over to the right, is it plus or minus? It's minus. So all of those are minus. We could have actually subtracted, right? We could have done a positive sign over here as well. But that would have meant without a calculator, we have to do 15 minus 42.5. Ooh, yucky, gross. We'd rather do cosecant of 5 pi thirds than that, wouldn't we? Yeah, that's okay. All right, so there's four of them. And of course, each of these equations right here have infinitely many subsequent equations that come from it, don't they? How far apart are all the critical values from these four? Like, where would be the next time? How far apart is this point here from this point here? The point going up and the point going up. How far apart are those from each other? 170. We call it the what? The period. What's another name for the period? It's the length of one cycle, but in science you call it the what? Wavelength. Yeah, it's the same thing. We talked about that. And of course, they used a different symbol. They used lambda, like that, which is kind of like an upside down Y that got tired of holding its arms straight up. It's kind of sagging. Now, here's something else I've mentioned. The frequency we mentioned in the very beginning is another way to measure the wavelength, okay? But remember, the period says we're going to look at one cycle and establish how long it takes for that cycle to be completed. The frequency establishes a time length, like 1 second, and then counts how many waves go through it. The frequency is related to the period. As I've mentioned, it's just 1 over p. So let's throw that in there. What would the frequency, f, we'll call that f, what would the frequency be of this function? 1 over 170. Yeah, there you go. Yeah. And this would be, you call this cycles, this is cycles per second. And what's another name for cycles per second in physics? It's not Avis, it's another rental company. Hertz, yeah. Yeah. Hertz. But we're not going to get into that until the next section when we start looking at applications of these sinusoids. Okay? So that's it. That's the notes. We got through 5.4. Okay? So your homework for 5.4 is due when?
Tomorrow at 9 a.m.
Tomorrow. Now, what I'm going to do, since I took a lot of your time, I thought I'd finish sooner. Um, I'm going to give you that extra practice worksheet to give right now, and I'm going to make that due not tomorrow, but we'll make that due Friday. So I'll give you an extra day on that. So let's just write that out here. So the worksheet for section 5.4 will be due on Thursday, bless you, at 9 a.m. And then the extra practice for section 5.4, which I'll give you, it's in Canvas right now. We'll make that due Friday at 9 a.m. Now, I do have a key for the extra practice worksheet, but I'm not going to give it to you yet. I'll post it tonight. I want you to spend the rest of class time today working on that on your own. And if you have a question on it, you can ask me, and then you can check your answers with the key tonight after I post it. All right, any questions? Any comments? Happy Wednesday. Today is International Happiness Day. Did you know that? Yeah. Yeah. All right. Yeah. Be happy. Be happy. Especially if it's your birthday. Am I right, Brady? Huh? I didn't even hear her walk in. I had no idea how long she was here. Did I make any inappropriate jokes? No. No? Okay. Whoo. Okay, good.